So we're asked to find the zeros of this polynomial. It's a fourth degree polynomial. That means it will have 4 zeros. And I'll tell you, 2 of them definitely will be rational. We'll definitely find 2 of them with synthetic division, because any zero that's not rational would require techniques we don't know yet. Like I said, the only thing we really know to find irrational zeros is the quadratic formula. So this will have to be broken down to a quadratic eventually. Over here I've got my list of potential zeros, which I generated by looking at things that go into the constant over things that go into lead coefficient. And I've done this problem a couple times, so I've already gone through all my false guesses. And so I'm going to kick this off with knowing that, like, I know that -2 is going to end up working. So 7, -14. I'm going to pause and carry out these calculations. So I've done my normal multiply, put the answer there, add these, put the answer there, multiply, answer here, add the inside, answer outside, so on and so forth, till I get down to 0. Now I don't know that I've explained why this necessarily means that this is a 0 with a function, but I'll say this is a division that we're doing, and the remainder is 0. So if that remainder is 0, that means that x plus 2 is going to be a factor. For sure, because if you divide something by something else and there's no remainder, what you have is a factor. And if you have a factor, then that number's got to be a 0, because we know factors and zeros are connected. And now I'm going to go ahead and stack this, and I would like do some more guesses. So maybe I try 5, or maybe I try 10, and eventually I'm going to come across -5, which is going to work beautifully. And we'll see again that what happens is we get a remainder of 0, which means this must correspond to a factor as well, so it must also be a 0. And I'm left with this quadratic. So this quadratic is not going to be factorable. There's no way you can write things that multiply to make 7x squared, things that multiply to make 1, and then have that inner and outer make a +2. It's just not happening. So I'm going to bust out the quadratic formula. X equals, therefore, the opposite of b, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. The inside simplifies to 4 plus 28 all over 14, which will be -2 plus or minus the square root of 32 over 14. And this is pretty good. And we've done a lot of work, but we have a lot of work left to do, because that 32 under the square root symbol, that could be broken up more. You know, if I think about all the perfect squares I know about and I try to consider if there's any perfect squares that divide 32, it doesn't take too long to realize that 32 can be rewritten as 16 times 2. And I'm going to always do this. If I see something under a square root symbol, I'm going to look to see if I can break it up. I'm going to use that biggest perfect square. I'm going to always write that biggest perfect square first. And now I'm going to go ahead and square root to 16 to give me 4 root 2 over 14. Sometimes kids make the mistake, by the way, when they see the square root of 16, they want to like break it down to 4, but then they want to break it down again. They want to square root this again. Don't. Once you square root to 16 and it becomes a 4, the square root's gone. That's what you have there. Now, this is close to what I have on the page, but there's one last thing, and that is all these numbers on the outside of the radical. This 2, this 4, and this 14, they all have a common factor of 2. I don't need to worry about the inside of the radical at all. Even though that also has a common factor, I don't care. This is safe from cancellation. Safe, leave it alone. But this guy, and this guy, they can all be divided by 2. So that would be -1 plus or minus the 4 divided by 2 is 2 root 2. 14 divided by 2 is 7. So you can write your answer like -1 plus 2 root 2 over 7, -1 minus 2 root 2 over 7. That's 2 different answers. One's plus, one's minused. Or you can break it up even further like I did on the note sheet, whichever you prefer. That's a huge problem. It's a lot of work. We got a lot of things in play there. So when you get through that, you should definitely take a water break, congratulate your brain, and then just like, you know. Oh wait, I didn't actually finish answering the question yet. Holy mackerel. I just didn't quite finish it off. So what are the zeros? The zeros are the -2 that we found, the -5 that we found, and then -1 plus 2 root 2 all over 7, and then -1 minus 2 root 2 over 7. So as promised, these are 4 different solutions. Here's one solution, here's a second solution, this big thing is a third solution, and that's the 4th solution. So good luck with that, and this is one of the more challenging things we're doing. So if this is giving you trouble, push through it, get it figured out. There will be some breathing room in a little bit, so don't worry too much.